In Chapter 20 of STM4, we think about inferences about means. This builds directly from what we did in the previous two chapters with inferences, both confidence intervals and tests for proportions. And here we're thinking about an example where we want to be doing some inference about the number of hours of sleep that teenagers get. In general, not enough, but that's enough for the life group. How can we actually be thinking about a normal model for this? Well, it's really due to the central limit theorem. Remember what we heard earlier was that if you have under certain regularity conditions, the distribution of the mean of observations will be approximately normal for approximately large enough sample size. So we can actually be using things um, with some kind of normal model. Again, this is assuming we know the true population standard deviation, sigma. So if we did, then we can use the 68, 95, 99, 7 rule, and we can go ahead and do our inferences based on what we saw from the sampling distributions. The problem is we don't ever really know sigma in practice. Why would we know sigma if we don't know the underlying population mean? And so the complication there is that we need to use something called Gosset's or student's t distribution. The t distribution is like a normal, but with slightly heavier tails. In this case, the solid line is the t distribution with 2 degrees of freedom, and the dotted line is the normal. And you can see the t has slightly heavier tails. What happens if we don't know the population standard deviation is we're going to go ahead and estimate it with our sample standard deviation s. If there are a relatively small number of observations, we're going to have a lot of instability of that estimate, which means we have to actually have those heavier tails to protect us, to give us the right inferential outcomes. The degrees of freedom are described here. There's more really of a complication, but what we actually get as you get sufficiently large sample size is that the t and the normal distribution end up being pretty much the same. So we need to have a little bit of a different multiplier, but for the most part it's very, very similar. And there's some examples here of using one sample t-tests as a way of kind of making these inferences. And we'll kind of see in a few minutes about how we can actually calculate these quantities needed for the calculations using R. So here's a picture of Fisher. And again, Fisher talked about some of these other conditions that are needed, this normal population assumptions, what kinds of things we can be doing in other situations. The just checking here is very helpful, talking about how these are structured and set up. I encourage you to be kind of working through that example, as well as this one example from the Think, Show, Tell in terms of the one sample test. You won't need to use the table to find t-values. We'll have equivalent software. In a minute, I'll talk about how we can be doing this using R. But it is valuable to actually go ahead and make a picture in the same way that we've done in some previous chapters. Drawing a picture really helps with some of the understanding. Interpreting confidence intervals is pretty much the same kind of thing we saw before. We can think about hypothesis tests for the mean in an analogous manner. And that's really kind of what's described in this next example, a one sample t-test for the mean with a think, show, and tell. So it closes with a little bit of an idea of what the kind of special case of proportions is and why we actually know the standard deviation in that situation. And then finally, section 20.5 talks about choosing the sample size, inverting these kind of calculations to be able to figure out what number of observations we need for our study. So, as always, some things can go wrong. Keep an eye on some of these things, particularly skewed data, because that may make it difficult to or inappropriate to invoke the central limit theorem, and kind of think about the learning objectives as well as enjoying the XKCD cartoons. Fitting things in R is pretty straightforward. We can reproduce the figure on the bottom of page 519 using the xpnorm command. We're gluing together some different examples here, and we can actually see a very colorful display that divides things up 2/3 in the middle, kind of gradually coming out later on. Equivalent thing, we can see the t and the normal distribution superimposed in that same kind of way. And we can actually calculate all of this using something called the t.test function. So here I could proceed to look at a histogram. It's good to see some data after so long. Favstats output, and then we can use that same information or kind of directly to calculate a one sample t-test in this fashion. If you want to do it by hand, there's ways described for you in this last part. Again, everything we've been doing for portions, now we can do for means.